All right. Good evening, everybody. Hope I'm audible.
Hello, good evening.
Good evening, Siddharth. Okay, so let's start the session. All right. So in yesterday class, what we have done, we have finished with this LLM folder. We have seen a couple of methods of calling the LLM, and of course, we have also seen the embedding model. And somebody was trying with this embedding model on a different query, and it was giving the wrong result. So I just implemented this test embedding.py as well on front of you guys, where we were using Gemini embedding 2, and with that, you see, it was giving the proper result with respect to these documents. It is state of the art embedding model, so of course it will give. Uh, but yeah, so that was about LLM part, and then we started with the LangChain prompt folder, this second folder. In this, we have covered the chat prompt template, right? This one, and we have also seen how we can apply it directly by loading our history. So till here we are able to finish it, and now we have to move forward. So this third file is similar to the second one only. I'm gonna skip this third file. Let's go to the fourth one, which is prompt template. And let's start our discussion from here itself. Okay. So since we already understand the chat prompt template, understanding the prompt template is not that difficult. So again, it's a class of LangChain, and this is called as prompt template. Now, as the name suggests, prompt template is useful if you are creating a single turn conversation. Okay, if you're doing a single turn conversation, in that case, prompt template is helpful. Whereas if you are creating a chatbot where you have to send the multiple prompts multiple times, so at that time point of time, we are going to use the chat prompt template. That's the only difference. Remaining code, as you already see, it's same. So here I have created my LLM or model, and then this is my prompt template class in which I'm setting two things. One is template, another is input variable. It's just a simple, you can say, message to my LLM. Over here, you see name is a variable that will be coming later. So hence, I need to define input variables in a list format. That what are the different input variables I have to give to this prompt template. And you see it's a name only because at the time of invoking this template, I have to provide it. So here I'm doing it, and once you're gonna print the result, like after calling the model, this prompt will go to the model, and model will be able to give you the answer. Simple prompt template, okay? Nothing fancy over here, but it was a class, so I thought let's discuss prompt template. Apart from chat prompt template, we have this class also available in the LangChain ecosystem. All right, now let's do one thing.
I have a question, Sachin. What is the difference between chat prompt template and prompt template?
I already told you, right? What you are listening. I mean, I said that
Uh,
chat prompt template is basically when you are doing a multi-turn conversation, and prompt template is just for one single message you are sending to the air. That's it.
okay, yeah, thank you.
No, no problem. Yeah, but please listen carefully. Okay. Uh, let's do one thing. Whatever we have learned till now, let's build a simple prototype of the chatbot. Okay, it's going to be a simple prototype. So I'm skipping this currently this UI part as of now, because for that I need to little bit talk about Streamlit as well. Let's go to this file chatbot7.py. So over here, what we are gonna do is we are gonna build a simple chatbot. And you see, first of all, I have defined my model over here. Again, you are already aware of this code. And from LangChain core.messages, I have imported system message, human message, and AI message. Now these three terms, also there is something called as tool message. You are already aware of it. Now this is my list I'm creating, chat history. And you see there is something called a system message. So over here, I'm setting my system message that you are a helpful AI assistant, and this is a list. And what I will do, whenever I, chat with my model, I will keep appending my chats in this particular chat history. Now you see the way I'm doing it. I'm creating a while loop. It's going to be always true. And here you are asking for the user input. And what we are going to do, once the user input is available to us, we are going to append that user input into this chat history uh, list with the help of this append method, right? So this will be appended, this message. And if let's say user has type exit, in that case we are going to break this loop, will come out from this loop. Otherwise we have to invoke our model with the chat history. So you see I'm passing my whole chat history in this model, and we'll get the result. We are going to extract the content of that result, and that result also we are going to append it inside the chat history, because one time it's going to be human message, next time it's going to be a AI message. So human message, AI message, human message, AI message. This is how your conversation will look like into the chat history. And on top of everything you will have this system message, because we are setting this manually first for the first time. And then finally, whatever result we are getting from the AI, we are going to also print it on the screen so that user will be able to see it. And then finally, let's say once this loop will be finished or will be breaked, because it will be only breakable when user is going to type exit, or if you just, hard break it by pressing Control C in your terminal. So we are going to finally print the chat history. So this is a simple program. We are just, trying to create a kind of chat GPT over here where we will be able to send the messages and we will be able to get the result with this simple, list. That's it. So let's try this and let's run it. CD LangChain prompts. So we run chatbot. Okay, so my bot got started. It does not have any kind of UI as of now. We are testing it through the terminal only. So it says, okay, I need to send a message. So let me just type, hey, my name is Sachin Mishra. How you are doing? So let's say this is my first message. Now you see AI has given me the response. Hi Sachin, I'm doing great. Thanks for asking. Now let me ask this question. Can you write a poem on my name? Now this time I'm not specifying my name. It should be able to understand from the history. Okay, let's enter. And indeed, yes, it understood. It says Sachin Mishra, a version of motion and whatnot. So it has written the poem. That's fine. All right. Now let me just say, do you know any Indian cricketer whose name matches with me? So yes, again, it is giving some kind of reply. So basically, it is able to remember the older conversation from our chat history. That's it. Okay. I'm gonna say exit, enter, and you see, as soon as I enter the exit, here is my whole, you can say, list, where it starts from system message, and one by one, all of the AI message, human message will be appended over here. For example, I can show you. Let's copy this and let's go here. JSON schema. You see, this is the human message. Can you write a poem on my name? And you will also see the AI message as well. You see, this is the AI message. So similarly, all of this AI message, human message, AI message, human message is available inside this list. All right. So just with this simple line of code, you will be able to, write your chatbot, which is going to act very similar to your chat GPT, which is going to have the memory, right? Now, there are some limitation of this code. First of all, what we are doing is we are maintaining our chat history through a list. And if you do this, you know that every model is going to have some kind of context limit. So let's say, if you keep talking to your chatbot, this chat history list will keep on expanding, right? And since it's going to keep on expanding, a time will also arrive where your model will not be able to take this input. It will basically say or throw some kind of error that context is full. You need to reduce the context. So we are not managing that context, right? So that is one limitation of this code. Second, you see, I stopped my program. When I run this program again, right? Let me run this. And when I'm going to ask, do you remember my name? So since this program got ended, all of my chat history variable were also loosed, because when you run this program, this chat history list is currently available in the RAM. And when the program closes, the variable which we are using chat history, it's basically gone from the RAM and we are not able to load the history again. For example, let's say if I have run the program again and let me ask this question. Hey, do you remember my name from the previous conversation? Let's enter. And it says, I'm sorry, but I don't have any record of your name. Because you see, we shut down the program, we rerun again the program, and we have lost all our variable. So this chat history is not persistent. It's not like, when you close the chat GPT and then come back again, it loses all your information. It does remember, right? Even for after 10 days, it is able to remember. So here there is no persistent chat history is going on. It's just a, in memory. You can say its chat history is just in memory. Whenever you are going to run the program, until the time that program is alive, then only you will have this chat history maintained. Otherwise, you are going to lose the information. Second, that was the second limitation. Third limitation, there is no user preference over here, meaning we are not maintaining any kind of user or session ID over here. If I run the same program and if somebody run the same program, system will not be able to distinguish, okay, which user is running which kind of program. So a lot of limitations are there, but a baseline is going to be this one. With this, you are able to basically create a bot kind of thing. But of course, this is not gonna work in a production because of these limitations which I talked about. Okay. All right. So let's keep moving. And by the way, we are going to see how we will be, going from this one to production level system. All of these limitations which I have talked about, we are going to come out from those limitations as well. Now, let's keep moving to the third one. The third folder says LangChain structured output. So we now have to understand the, you know, what is structured output in the LLM and why do we need that? So currently, a lot of LLMs, when you see all the modern LLMs, they possess a very, you can say, a good quality, structured output quality. So meaning, let's say if you ask a LLM that this is my data and I want a structured data extraction for this particular information, they will be able to give you very structured information. So since LLM possesses this information, and when we talk about the backend system, in the backend system, all the data flows with respect to JSON schema, right? JavaScript object notation. So LLM are also good in that, and hence, if we are building any kind of system, LLM is just going to be a part of it. And to use the LLM, sometimes it is required to generate structured kind of data or JSON kind of data, maybe CSV kind of data, any kind of structured data, basically. So let's try to see how we will be able to generate a structured data with the help of LLMs. Okay. Now, in order to generate the structured data, we'll have three ways in LangChain ecosystem. Actually, these concepts are inherited from Python only. The very first way is type dict. Second way is JSON schema. Then we have something called as pydentic. So we are going to see all of them one by one. So first of all, let me just give you the brief idea what is type dict. Once you understand what is type dict, then we will be able to understand, okay, how we are going to extract the data with the help of type dict. So anybody over here, understand what is type dict? Anybody have heard about type dict earlier?
It will give us a type of means fixed data type that will supposed to be sent through the API and supposed to be sent received also. Means the type of messages or the
Mhm.
parameters, all the data types will be predefined.
Kind of, yes, you are right. But type dict is little different. You are close to 60-70%, but it has more information. So yeah, let's discuss this. So first of all, type dict, as the name it is saying, it's a data structure. Okay, it is data structure in Python. And what kind of data structure? It's a dictionary kind of data structure. And you see, the way you are going to use the type dict, we are importing this from typing. So typing, you don't have to install this library. It by default comes with the Python. When you install Python, it also by default comes with it. So what I'm saying from typing import type dict. Now, if you have learned about dictionary, you see the way we create a dictionary is we have this, D equals to maybe your key and then value, right? This is how you create your dictionary. So what is the difference between dictionary and type dictionary? So type dict says that it's basically gonna give you the type hinting prior to defining the dictionary itself. And the way we do it is simple. You see, I'm writing a class over here. It's a person class, and I'm importing this class from a type dict. So, sorry, I'm inheriting this person class from type dict class. So this is going to be a parent class from which this person class is inherited. So basically, it is gonna inherit all the property of type dict. And in this particular class, I have defined two variables. One is going to be name, age, and you see, I have to already define the data structure of it. Data type of it. So name is going to have the string kind of data type. Age is going to be int type of data type. Okay. Now, over here in this line, you see what I'm doing. Change this, yeah. So what I'm doing over here, I'm saying let's create the object of this person class. So the object is new person, and this is also a syntax of Python. You can write it in this way: new person colon persons. So this is in this way you will be able to create the object of this person class. And then you see in the curly braces, meaning it's a dictionary format. First of all, I'm setting my name, which is going to be Sachin, and then age, which is 32. I'm just written over here, and then I'm just printing the new person. So let's try to print this and see what it gives. CD dot dot LangChain structure put. We run type it, and you see it has printed this. And let's say if you try to print the type of the same thing, type of the new person. So you see it says dict. So it's a dictionary object only, but when it is inherited from type dict, you have to define the data type prior to defining your dictionary. So that's the only difference. It is very similar to dictionary only. Just it is gonna give you the type prior to defining your dictionary. By the way, this concept is already available in other languages. But since Python is a dynamic language, right? The data type is not defined at interpretation time, it is basically defined at runtime. But with the help of typedict, you can also define the data type while writing the code itself. So this is it. But here is a catch of this typedict. Typedict is a good library, but it does not support any kind of data validation. Meaning, so let's say you see I have written age as it's going to be integer, and I'm passing integer over here, which is fine. But let's say even if I pass 32 in this manner in a string format, it's not gonna complain, it will run. So let me run this, and you see name Sachin, age 32. So it is not doing any kind of data validation. So it's a good library, but does not have any kind of data validation inbuilt available in it. Okay. So that was about typedict. Now let's try to create one program with the help of which we will be able to basically generate a structured output with the help of typedict. So the use case I have is this is one of the review. Okay, somebody has given on the Amazon, or maybe any place you can just consider. So it's a review kind of thing. We have this whole bunch of text, and what I want to build, I've just changed it, reviewed by Sachin. Okay, review by Sachin Mishra. Now what we want to do is basically we want to take this entire sentence, we want to send it to the LLM, or maybe paragraph, we want to send it to the LLM, and we want to extract lot of structured data from it. For example, I want to extract key themes, summary, sentiment, pros, cons, name. So these are the key attributes I want to fetch from this particular sentence. Okay. Now, since LLM has understanding of the sentences, of course they will be able to give all of these things to you. But we want this data into a structure format. It's not going to be, we don't need in a non-structure format. So how we are going to achieve this? So you see, this is my LLM setup. Till here you understand the code, and from typing I have imported a lot of things. One is typedict, which you now understand what is typedict. I have imported annotated, optional, and literal as well. We'll understand what is this annotated, optional, and literal. So let's come over here and let's try to first define our schema, which we want to extract from the LLM. So you see, I'm defining my schema. I'm giving the name class review, and it is inherited from the typedict, right? Now, I've written all of my fields which I want to extract. First of all, it's a key theme. And you see, now here I'm using annotated. So with the help of annotated, what we can do, we can annotate the data type of this particular variable. And it's going to be what? It's going to be list of string. So that's what annotated does. Now you might ask question, okay, if I simply write this list of string, doesn't it's gonna work? It's gonna work, but annotated just ensure that it always comes as a list of string. So this annotated is having some kind of built-in checks available, which will always check whatever the result is getting generated, is it in the form of this format only or not, right? It's going to be list of strings. So that's why we need to use annotated. Annotated is basically gonna annotate that data structure or that data type. And you see, we are writing a one-liner description. So for the first key themes, I have written that write down all the key themes discussed in the review in a list. And similarly, for each and everything, you see, I have written a description, one-liner description. Now, why this one-liner description is required? Because when we are going to send this entire sentence to LLM, along with this sentence, we are also going to send this entire schema to LLM, and LLM is going to read all of this schema, and this will basically, this description is going to help LLM while producing the JSON schema or JSON output for us. Okay. That's why this one-liner description is required. All right. So this is clear. Now let's talk about this literal and option. So you see in this sentiment, I need a sentiment as well. So what I'm saying, I need a annotated sentiment, of course, but it is going to be literal of POS and NEG, meaning I only want two kind of sentiment. One is positive sentiment and another is negative sentiment. Now, let's say, if I remove this literal and if I just write, it's going to be a string of positive or a negative, some LLM is going to give the answer, but sometimes it is very much, possibility that LLM might give you a third kind of sentiment, which is going to be neutral. So it can give positive, negative, or it can also give the neutral. But I don't want that neutral sentiment extracted. I only want two fixed kind of sentiment to be extracted. And that's why I'm saying literal, meaning it's going to be literally have only these two things, positive or negative. That's why we are using literal over here. Okay. So it's going to be give me the positive or negative. Apart from that, it doesn't gonna give me anything. And then you see when you write optional, so meaning this particular pros or cons and name we are using optional. So meaning this is going to be optional fields. If it is not available in the sentence, LLM is not going to give any kind of attention. It will basically ignore these fields if it is not available. If it is available, of course, LLM is going to give the answer, but they are optional. Okay. So that is how we are combining typed it along with this annotated and optional in order to have little bit of you can say data validation, but still it is not a foolproof data validation. But fine, this is gonna work perfectly fine. So let's try this. Now I have my schema ready. Now what I have to do, first of all, I have my model, and in LangChain there is this library called as with structured output. So what I'm doing, I'm combining my model. You see, this is my model, and I'm calling a method called as with structured output. And in this method, I'm passing my schema. And when you do this, it is going to give you one object. So I'm constructing the object of this particular method. And that object, I'm calling it as a structured model. Because here, what we are doing basically, we are giving the information of our schema to the LLM or to the model. And that is, I'm calling it as a structured model. Now, once I have this structured model available to me, I can simply invoke it with my entire paragraph, which I have. So this is how you will be able to, basically give your schema information to your LLM. All right. And then finally, you see whatever result it's going to give, I'm going to print it. And I'm just trying to extract the, name from that schema, because now it will be available in a JSON format. And since it is in a JSON format, I can simply say, result of the key value. So basically key, I'm passing name, and it should return me the Sachin Mishra as the value. And we are also printing the whole result in order to check what we are getting the whole result as. So let's try to run this and see whether it works or not.
Sachin, one request. Can you mute the other participants because it's too noisy?
Sure, Akash. Yeah. All right.
So, Sachin, whatever we are able to achieve using type dict, can't we achieve it using normal dictionary?
In the normal dictionary, you won't be able to define the scheme. I mean, the type of data type predefined, right? I mean, it will be evaluated at runtime, because Python is a dynamic, right? It's a dynamic language. So you won't be able to define this prior to it. And let's say, if you have not defined this, instead of string, LLM might give you the answer in a list format. But when it comes to structured data, it should be really structured the way we want. That should be it should follow basically the behavior of the data type. And hence we are using this type dict.
Okay. Thank you.
And you see, we receive our output. So this is my JSON schema. JSON is called as dictionary in Python. You already know this. You see, it has given cons, it has given the key themes, it has given the name. And when I extracted the name, you see, it is able to give me Sachin Mishra. So you see, this is the output. You see, it's in a dictionary format directly coming from the LLM. And it is also following the data structure type. You see, the cons, we have written cons should be list of strings. So that's why it is giving the, in a list format, all the cons to us. Key themes also should be list of strings. So you see, it is following that schema. Name is going to be only a string. So that's why name is available in the string format. Pros is going to be list of string. Sentiment, you see, it is only giving this positive POS, nothing more than that. Summary, it is giving in a string format, you see. So it is able to follow each and every instruction, and it is able to give us the output, structured output. And you see, when you build the system, right, a backend system, because all of this LLM lies where it is in the available, it is going to be available in the backend system only. So backend is nothing but, you know, the flow of information only. A JSON data will flow from here and there, and hence, you know, it is required to generate the JSON schema from the LLM as well. What I'm trying to say right now, maybe if somebody like coming from the backend engineering, they are able to understand what I'm trying to say. But let's say if you're not able to understand why we need this JSON schema as of now, don't worry about it. Once we are gonna build the systems over there, you will understand, okay, why we'll require this JSON only. Okay. But those who are done a little bit of engineering, they are able to correlate that why do we need a JSON schema. Okay, so let's keep moving. Now let's go to the Pydantic.
Hi, Sachin.
And yeah, Shivani, please go ahead if you have any question.
Yeah, actually, I have joined little late. Sorry for that. But can you just, in a very brief, if you can just tell me the difference in type dict and dict? Like, I know the dict, but what you're trying to do with dict, type dict here? Just
Type dict is just a data structure with the help of which you will be able to, you know, before runtime only, you will be able to give the data structure, so data type of your variables. So you can define that. It is similar to dictionary only, but typed it, the way you are use it is in this way. So you see, in the dictionary, we just say name and age and directly run the code. At the runtime, it will, when you are gonna pass the values, it will decide, okay, name is going to be in a string format, age is going to be maybe whatever format you want. But when it comes to typed, you have to, you know, define your data type before running the program. That's the only difference.
Can we do it with the like Pydantic schema? Like in that also we define by base model, keeping base model inside it. Is it like the same?
We are coming to it.
Okay, sure. Thanks a lot, Sachin.
Yeah, no problem. All right, so now let's talk about the Pydantic demo and why do we need to use the Pydantic. So first of all, the problem we have with the typed that it does not have any kind of data validation. Pydantic, you know, solves that particular problem entirely, and not only it solves the data validation problem, it comes with a lot of other data validation fields. Like for example, you know, if you want to validate email, whether email format is right or not, so you don't have to write your custom code for that. Pydantic comes with this something called as this email string, which is not available in the Python by default. So if you're going to use this, you will be able to validate your emails as well. And not only emails, Pydantic comes with a lot of other data validation tools as well. So Pydantic is a complete ecosystem. And in the production, we use the Pydantic one, not the typed. Of course, if you want to combine Pydantic and typed, where, you know, let's say if you don't want to validate your data, at that point of time, typed is fine because it's a lightweight. You don't have to install any other library. But when it comes to Pydantic, you have to install this library called as Pydantic. okay, then only you will be able to do the data validation. So let's say if strong data validation is required, then we will always go with the pydantic. Okay, otherwise typedict is also fine. Now let's try to understand. So first of all, you have to install this by saying uv add pydantic. I have already done it. Now from pydantic, you see I have imported three things. One is base model, email string, and field. And from typing, of course, I need an optional one. So I have imported that. Now the idea is going to be the same. You again have to write the class. And this time what we are doing, just basically understanding how pydantic works. So I'm taking a student class schema over here. It is inherited from this base model. Now base model is coming from the pydantic. So this is the, basically you can say it's a class where all the pydantic schemas are mentioned, all the data validation is mentioned. So from base model, I need to create a class called a student. And here I have given name, age, email, and CGPA. You see, name is going to be in a string format. I've just given a default value as Sachin. You can change it. Age is going to be integer and it's optional. You can set it as, none. That's also the facility given by the pydantic. It's a little advanced library. And then email should be in this format, email string. Again, it's not a built-in data type of Python. It's a data type available inside the pydantic. And with the help of this, you will be able to validate the emails. And then you see, I have written one more field over here, CGPA. And pydantic also gives you the, this kind of features that you can define the range as well. So CGPA is going to be float, but it will have a range. The range is going to be greater than 0. So this particular thing is called as GT, greater than 0, less than 10. Default is going to be 5. And this is going to be a description so that when your LLM sees this, it will be able to produce it properly. So you can also provide the description. And whenever you have this kind of information, you have to use this field. And that's why we have imported this field. Okay. Great. Now, what I'm doing over here, so I'm saying new student, it's going to be a dictionary. So I'm saying age is 32, email is abc@gmail.com. And you see, I'm purposely saying that age is 32 and it is available in which format? It is available in the string format, because I want to see whether this tool fails this or passes this, what happens, right? So I want to check it, and purposefully I'm passing age as in a string format 32. So this is my dictionary object I have created. And now I have to do what? I have to basically create the object of this class, student. And the way you are going to pass this dictionary new student, you have to use this 2 star symbol, and then you have to pass this new student. Okay. And then what we are doing, we are just printing the student, printing the type of the student. Let's check till here only. Let's see what we get. And then I will explain you the below code. Okay, so you see, even though I passed it as a string, my program doesn't fail. In fact, it got passed. And when you see, when I printed the student, what I'm getting name as Sachin and age is 32, but pay attention over here, age automatically got converted into integer. Even though I passed this as a string 32, it got converted into a integer 32. And email also, it is it has printed, and CGPA I didn't have pass anything, so it is capturing the by default value. Also for the name I didn't pass anything, so it is taking the by default value, right? So it is able to print it. And when you check the data type of it, it is saying it's coming from the student class. So that's a class from which this object got created. Now, why is that happening? 32. So Pydantic, it tries to convert this 32 string into a integer, and if it is possible to convert it, it's gonna basically parse it automatically and then give you the output. So that's the power of Pydantic. But let's say instead of 32, let's say even if you write 32.0, it's gonna work perfectly fine, because still this is also convertible into an integer format. You see? But if you change it completely, let's say if you pass the age as maybe something really wrong, so let's say what will happen. You see, it is giving the error. It is saying input should be a valid integer unable to parse string as an integer. So it tries to parse this, but this is not convertible into an integer, hence it is giving the error, right? So it has the by default parsing ability as well. And if it is not able to parse, it's going to give you the error. Now, currently you see till here, if you run this program, what we are getting is the object of the student class. But let's say, if I want to convert this into pure dictionary format, so I can do that. I can just have to say, let's do this, convert this student into a dictionary, and you will be able to see the pure Python dictionary as well. So let me run this in order to check. You see, now it got converted into a proper dictionary. So once you have the Pydantic object, you will be able to convert it into a pure dictionary as well. All right, now let's do one thing. Yeah, this is fine. You can do that. Now, over here, what I'm doing, so with this particular line of code, I do have this student object, and what I want to do, since it is coming from this student class, I want to make it as a JSON object, okay? So that's why there is a method called as dot model dump JSON. So in this student object, all these values which you are seeing, it will be automatically converted into a JSON format when you use this dot model dump JSON. So let's try to see how it looks like. And by the way, JSON is nothing but a dictionary in Python. Remember that. So let's run this. And you see, now we are getting the proper JSON schema. And when you now try to print the type of it, it will be a dictionary only. Let's run this. Sorry, we have converted it into a JSON, so it is going to be in a string format. If you want to convert it once again back to the dictionary, so you have to parse this string to dictionary. So you just have to do one more typecasting as a dictionary, because JSON or by default comes under the string category. So with the help of this, you will be able to convert it into a dictionary format, JSON format. And again, if you want to do the typecasting, you can just say dict of this, and it will be converted into a dictionary format. Okay, so this is how your Pydantic works with built-in data validation as well. Now let's see.
So, Sachin, sorry to interrupt.
Mhm.
Here, data validation happened just because it is inheriting base model, which is nothing but Pydantic, right?
Yes,
Whereas
yes,
if we had kept type dict, then it wouldn't have been possible.
correct. You're right. But
Ah,
typedit also don't give you this kind of features. So if you use this field,
yeah.
email string, all of these are coming from the Pydantic only. It will not come from the typedit.
Okay. And
Typedit
we
doesn't have this.
also did not use annotated keyword here.
You can use it. So we are
Okay.
gonna just see
Okay.
in the next one. Yeah.
All right. Thanks.
All right, let's go to the next one. So now this time we'll take the same example, you see, same example, but this time we are gonna use the Pydantic base model, and remaining each and everything is same. You see, we are using literal, optional, everything. Same way with structured output, the function is same also. But only the difference is the schema which now we are building is with the help of base model, so that there is going to be a inbuilt validation. So let's say, LLM will generate an output. After that, this Pydantic will do the external validation on top of that, so that we won't have any kind of problem in terms of our schema. Let me run this and see. So yes, we are getting the result over here in a JSON format. Okay, it's a string format, but you know that in order to convert it, you can simply say this one dot model dump JSON, and it will be basically able to dump it into a JSON format. Simple. So that was about the Pydantic one. Now, apart from Pydantic, you can also use this directly. So you can define a JSON schema in this way. This is another way of doing the same thing. You see, I'm writing my JSON schema into a dictionary format or a JSON format. So I'm writing each and everything, so that my title is going to be this, type, properties, key themes. But this is not a very, you can say, developer friendly, because you have to write each and everything in this way. But sometimes, LangChain also gives you this functionality. You can use this also with this particular method with structured output, and it will give you the similar kind of result. But we don't avoid this, because you see, if you have to write this entire structure, it's going to take a lot of time, and it's not a developer friendly. But yes, this is also a option available, and hence I have just put it over here, that you can go in this way as well. And then there is something called as yeah, let me do one thing. Let's go to the sixth one. And right now we have seen that when we were using the Grok LLMs, we are able to generate it. But now let's try, the same output. I mean, the same code, this which we have written for the Pydantic one. But what we are doing, we are only changing our LLM part this time. We are not using the Grok LLM. So over here, you see, we were using the Grok LLM, but now what we are doing, we are using this tiny llama model, which we have already seen from the Hugging Face. Okay. And on top of this, with the help of this particular model, we want to generate a structured output. And let's see, are we able to do it or not? Okay. And you see, as soon as I did this, it is giving me error, not implemented error. Pydantic schema is not supported for function calling for this particular model. Now, why is this happening? So first of all, let me tell you, each and every LLM which you see in the world, not every model, support the something called as there is something called as function calling. So over here, what we are doing actually, we have implemented a function calling, and by the way, function calling is also called as tool calling. When we are going to learn about the agents over there, this name will just change. Function calling will be called as tool calling over there. And now let's try to understand what is function calling, what is happening over here. So you see, when you give this review schema to your LLM with the help of this function or this method with structured output. So basically, you are binding your LLM with this schema so that your LLM will be able to call this schema when this input will be passed. And whenever you are going to force this is called as function calling. So basically, we are giving a LLM a certain function which it will be able to use whenever it is required. Okay. And not each and every LLM comes with the function calling functionality. And this is one such example. When you use this tiny llama model, which is available on Hugging Face, it's a very low model. And I think it before I think even Llama 3 model. And at that point of time, when LLM was being produced, they does not support any kind of function calling. But recently, whatever the modern LLMs you see, maybe GPT-4, 5, or maybe Anthropic models, Gemini model, they all support the function calling feature. But you have to remember this, that not all the LLM supports the function calling. So you have to evaluate. Currently, now, like nowadays, each and every model supports it. But again, I just recommend you to check which model supports the function calling or not before implementing anything. So there is nothing wrong in this code. The problem is this model itself does not support function calling. So it is not able to generate structured data because it is not trained in this kind of data. And hence we are getting this error, that not implemented error. Pydantic schema is not supported for function calling for this particular model. Okay. So that's what I just wanted to clear. We'll talk about, more on this function calling later, but from here, actually, it all started. Any question, doubts?
Within one question. So Pydantic is being called maybe by the LangChain to convert data coming from this tiny llama. So it is a problem with model. It's not able to give the structured output.
Yes, it's a problem of this particular model that it is not able to give structured output. It will not be able to generate the structured output. So hence when we are, combining this model with this particular method with structured output, it is failing. That's the problem.
Okay.
And Sachin, what happens if we directly invoke without using the with structured output method and pass the review?
Yeah. So in that case, what will happen? And by the way, what this method is doing, so it's a good question. So let's say, you don't use this, you directly send this your schema to LLM. Now there is high chances that yes, your model will give you the proper output. But what this with structured output method is doing, so internally it has implemented a prompt, and that prompt basically enforces your LLM to always produce a structured output. That's what this method is doing, nothing more than that. Now, let's say if you send this entire data, I mean the entire schema without this particular method, so 90% or 95% chances are there that you will get the output. But there are 4-5% chances that LLM might get hallucinated and it will give you the output which is not matching your schema. Maybe it will match your schema, but data structure will not match. And this method LangChain team has developed by a lot of iterations. So you pass any kind of schema, they will handle it very well, and they based upon that a dynamic prompt gets generated that okay, based upon this schema that you have to generate the proper, you can say, structured output. So that's what they are doing it. Hence it is recommended to use this particular method whenever you are working with the structured data.
Okay, thank you.
Yeah, because you see in the production, let's say even for 1 or 2 cases, if you are not able to generate the structured data, so it will basically, the data will not be able to come from your model to the next system, and over there it will fail. But by the way, let me tell you, let's say if you are working with a very strong model like Fable 5 or maybe Opus 5 model, these model are very strong and you don't require this kind of with structured output. Even currently I'm working on a project in my company where we are generating, you can say, 3000 line of JSON schema, where we are having kind of executive summary, and then lot of, you can say, task IDs, lot of basically fields are there, and over there we are using the Opus 5 model, and we are not using any kind of this with structured output. But trust me, if you are using lower models like GPT-4, GPT-5, over there you will require this structured output because over there it will start failing. And when it comes to models like Opus 5 or Fable 5, which is not gonna fail, they are, I mean, 100% they are gonna give you the output. But to run, just to produce one single JSON schema, it is costing us $10 to $15 only for one run. So it's a very costlier model. If you want your model to be little cheap, like GPT-4o mini, in that case, it is recommended to use this with structured output, so that you will be basically double ensure that whatever output you are getting, it is being generated properly. Okay.
Yeah, okay.
Any more questions? All right. Awesome. So with that, we have covered this structured output. Now we have to start with something called as output parsers. Okay. So let's try to understand what is output parsers. Now in LangChain ecosystem, there are multiple output parsers are available. One is we have something called as string output parser. Then we have something called as pydantic output parser. And then we have something called as JSON output parser. These are three majority one, but there is something called as XML output parser. There is something called as CSV output parser. There are a lot of other things, but generally, majority of time we use only these three. So I have included these three over here, but maybe after the class, let's say, if you want to just check it out, you can just go and check the documentation for XML output parser and CSV output parser. Anybody knows what is XML here? What is XML? Anybody? XML data type? Okay. Anybody? What can tell me, Raj? What is XML data type?
I mean, I have just seen it. We deal with XML data type, Sachin, just as an ingestion to
Right,
our
right.
pipelines. Just one data format, similar to JSON.
Correct, correct. So you are right, correct. It's just a JSON format, data type format. So if you learn about how JSON works, you will be able to parse the XML, and LangChain output parsers does support the XML output parsers as well. So let's try to first understand why the hell this output parser is required. Okay, so output parsers, as the name suggests, it is going to parse your output generated by the LLMs. Okay, hence the name is output parsers. So whatever LLM is generating, we need to parse them properly. And if we are able to parse them, we should be able to send that data to maybe for further processing or maybe for further systems. Hence, this output parsers are required. Now let's try to see this particular code, and I will try to explain you what is going on here. So I'm using this Gemma 3-4 billion model from, once again, Hugging Face endpoint. I don't know if it will throw any error, then we'll change the model, but let's try to use this. I tried last day and it was working. So let's try to use this. It's an open source model. Okay. And you see, I'm creating one prompt template over here, and this is my template one. This says that write a detailed report on topic, and topic is going to be my variable, which will be coming from the user or maybe on a later stage. And then I have a template number 2 where I'm saying write a 5-line summary on the following report. And you can call this as a text or report. So let's just change it to report instead of calling it as a text. All right. So once my once I will have the topic, it is gonna write the report with the help of this prompt template. And then in the next prompt template, I need to write the 5-line summary on that report once that report will be generated. Okay. Now, you see what I'm doing over here. I'm invoking the first template. So this template number 1, I'm invoking and passing the topic. Let's say black hole is the topic. So it will give me the whole prompt, which will be available over here. And then what I'm doing, I'm invoking my model And what I'm doing, I'm passing a prompt one over there. And this will, of course, is going to give me the result, right? Now, in this result, what I will have? I will have the detailed report on the black hole, right? Now, if I want to generate a 5-line summary, so what I have to do, I have to pass it to my template 2. So I'm invoking my template 2. And in the report, what I'm sending, the result which is generated by the LLM, the content of it. And that what I'm calling as a report. And then again, I'm invoking my same LLM with the prompt number 2. So this is a state. So what we are trying to basically build a Gen AI application, a simple Gen AI application, where we will have, first time a user is going to type the basically topic. So user has given a topic. With that topic, what we want to do, we want to call the LLM and generate a report on the black hole. Once report will be generated, we want to basically take that report and we want to generate a 5-line summary on that report. So it's a 2 LLM call and it's in a sequence, right? It's in a sequence because let's say if your report is not generated, you won't be able to write a 5-line summary. So hence it needs to be in a sequence. So we are calling the 2 models in a sequential manner. That's what we are doing it over here. And finally, whatever result is we are getting, we are printing it over here. So till now, there is no structured output I'm using and I'm doing this. Now let's try to run this and see what we are getting. We are just, finally printing the result 1.content, meaning the final 5-line summary will be printed. Apart from that, nothing will be printed. Okay. So let's run this. So it is calling the Hugging Face model. It's gonna take some time. Let's wait. Great. So this time, I mean, it worked for the first time, the Hugging Face model. And you see, we are doing the inferencing on the Hugging Face server, not on the local server. So you can take this model. This is working. For the first time, at least I was able to demonstrate in the class. So Hugging Face, kudos to you. Okay, now you see this is the 5-line summary it has generated on the black hole, which is fine. But here you see we have to write 2 times like the code basically in order to invoke the model. And in order to basically avoid this kind of situation, output parser comes really handy. Now I'm going to show you one more code. So let's go over here. String output parser, where I'm going to use it. So you see what I'm doing. I'm saying LangChain core output parser. Let's import something called a string output parser. So it is available in this LangChain core output parser. Okay, string output parser is available in this particular library. And LangChain core, we have already installed it, so no need to install it again. All right. And this time I have just changed the LLM. If you want to use the previous LLM, that's totally fine. It will work on a similar manner. Again, I have defined my prompt template 1 and then prompt template 2. But this time what I have done, I have defined my parser over here. And this parser is an object of string output parser class. Now, when I do this, you see my code now become in this manner. So what I have told you that we are having the LLM over here. And we are sending the data to this. And the first time what we are just sending, we are sending the topic, right? That's it. Then this is going to give us the report. So earlier we have to take this report and again we have to send it to LLM as an input. And then LLM was giving us the output. So this was the flow, sequential flow, right? Now, in the classical LangChain, which we are currently learning, they have, identified this particular problem and they have built something called as chains. So if you see this properly, this is nothing but a sequential chain, right? Because what you are doing, you are calling the LLM one time and then second time with this report as an input. So it's a calling to LLM instance in a sequential manner, and hence it is equivalent to your chains in the LangChain. And from here actually, LangChain team has given their library name as LangChain because they are building something called as chains. And from here, the name also came like LangChain. And this is the heart of their library basically. So let's come over here and you see what I have done. After building this parser, I'm writing a sequential chain over here, and this is you can say syntax of LangChain. It is called as LCEL syntax, okay? LangChain expression language. Now what we are doing over here, you see my template one is first coming into the picture, and then I'm using this pipe operator, okay? Pipe operator. So input of this template will go over where it will go to the model. Output of that model will be parsed by this parser. Hence, we need to use the parser. So because whatever the output, so first time model is going to do what? It's going to generate the report for us. Now report it's going to be in a string format. Result.content we have to write, right? So earlier we have to write this. This one, you see this result.content. But since we are using the output parser, we don't have to write this. We just have to use this parser. And then pipe operator, it is automatically going to parse it. So that will become the input for template number 2, right? And then output of this template, this template will be fed to the model, and then model, whatever output it's going to generate, we again going to parse it with the help of parser. And usually LLMs gives you the output in a string format only. Hence, we are using this string output parser. And then I'm calling this entire thing as a chain. But this chain need input itself in order to start, right? So this template is the first block of this chain. And then you see what we are doing in this, in order to run this chain, we are invoking. So hence invoke method is there. And we are passing the topic as black hole. So this time you don't have to pass the topic and then you have to pass the report. It will handle each and everything internally. So combining the output parsers with chain makes sense actually. If you're going to use the output parser alone, it is not very useful. But when we are going to combine this output parser with chains, over there its true potential you will be able to see. So you see now we are just invoking this chain, that's it. And the result we are just printing. We are not just saying result.content this, that, because different LLMs will have the different kind of parsing techniques. And this string output parser is going to handle each and everything, okay, for us. And now let's try to run this and see what it gives. And there you go. We got this 5-line summary on this report, okay? Report, we are not printing it. We are just finally directly printing the 5-line summary. That's it. If you want to print the report, that is also possible. In between, you just have to print that. So this is how this structured output parser is working with the chains. And now just imagine, let's say, if you want to call your LLM multiple times for different input, you can build this kind of sequential chain at, and the chain can be it can be up to any length. Okay. So you can build this kind of chain and then you can just have to invoke it. And this type of chain is called a sequential chain. Next, we are going to learn the chains. There are a lot of other types of chains also available in the LangChain. but this is just one type we have understood, and we have also understood how string output parser works actually. Okay, now let's keep moving. Let's go to the JSON output parser. So again,
Sachin, I have a question in the previous one.
yeah, Akash, please go ahead.
Yeah. So in here, like we are still calling LLM twice, correct?
We are not calling the LLM. You just have to write in this manner, right? Otherwise, you see, you have to write this in this particular manner, model.invoke, model.invoke. Of course, LLM is internally getting called twice, but you
Yeah,
don't have
okay.
to write it. This is the
Okay.
way you write.
It's just the like format change, like
Yes, yes,
lesser number of lines. Okay. Yeah,
correct.
thank you.
Right. Anybody have any more question on this? Okay, no questions, fine. Now let's go to the JSON output parser. So again, JSON output parser is coming from this LangChain core dot output parsers, having our LLM over here. Now, this is little bit different than a string output parser. So JSON output parser, you have to use, so you see currently like what I'm doing over here, this is my prompt template. And what I'm saying in a template that give me 5 facts about topic. And then since we are using this JSON output parser, I have to add this line, and I will just say /n format instruction. When you add this line into your prompt template, your chains will understand, okay, the user want to use this JSON output parser. And also now this is going to be my input variable topic, which I will be giving from here. Apart from that, this format instruction, right? This format instruction is a variable. You see the way we are writing this, it's in a curly braces. So it's a variable. Okay. Now this variable needs to be given from somewhere. And the way we are going to give it, we have to use this something called as partial variables. In the same prompt template, there is a one argument called as partial variables. And in this partial variable, we have to pass this format instruction. And how we are going to do it? So we'll, first of all, this parser object from the JSON output parser is available. So we'll have to call that object, and dot, there is a method, inbuilt method available in the LangChain itself. We have to call that get format instruction. Now, when you call this, it basically internally create one system prompt once again for the LLM. And that system prompts will be feeded over here. And that system prompt says that, okay, we have this particular request and you have to basically give the JSON output for us. That's what this particular method does for this. Okay. Now, you see, I'm passing the black hole as the topic once again. And it says, give me 5 facts about the topic black hole, right? I'm invoking that chain. And the way I'm creating the chain is this template. It will be given to the model. And finally, it will be parsed through the parser. So we will get the all these 5 facts in a JSONified format. Okay, not in a string format. And who is instructing that? Basically, this get format instruction. Now you might ask a question over here that, okay, why we are not using Pydantic if we need a JSON output? So you see, we are not forcing our LLM to give the JSON output. Whatever output will be produced by the LLM, after that, we are using basically this kind of JSON output parser in order to basically create the JSON output. So it is after the LLM call, not into the LLM call. Whatever answer we will be getting from the LLM, over there, we will be basically parsing it. Okay, that's what this code says. Now let's try to run this. UV run JSON output parser. Let's run this. Yeah, and you see, now we are getting the output, and each and every output is like available in the JSON format. So it says black hole facts, fact number one, and all the facts are available in the list format. And inside the list, you have nothing but key value pairs only. Fact number one is this, fact number two is this, so on and so forth. Right? So this is about like JSON output parser. Only thing is you have to say this format instruction, and this format instruction should be coming from this partial variables. Now let's jump to the pydantic output parser. And it is like not a different than your string output parser. So, and by the way, these output parser, sorry, this one, let me go here. These output parsers, these are over here basically, they help us basically. So these kind of models, Google Gemma 3 4 billion it, which does not properly support the any kind of output data, sorry, structured data generation for us. On these kind of models we can apply this kind of JSON output structure. Okay, so earlier if you remember, we are not able to get this structured data on this model which I've shown you. Let's go over there. This one, Tiny Llama. Similarly, this particular model also does not support the structured output, but with the help of output parser, we are able to generate the output parser also with these kind of models. Now let's come to the pydantic one. So pydantic one is, once again, you see it is available in the LangChain core.output parser, from where I'm importing the pydantic. Here is my LLM setup. Now again, I have to, first of all, since it's a pydantic, so I need to write the schema. And the way I need to write the schema is from the base model. Okay, and let's say this is a simple use case. I want to extract only name, age, and city. So I've defined it over here. And then what you have to do, since we are using this pydantic output parser, so I have to pass this schema into this particular class, pydantic output parser. So I pass that schema, and it will give me a parser object. And same, the way I have used the JSON output parser, on a very similar basis, I'm going to use this pydantic output parser as well. So in the template, you see what I'm writing: generate the name, age, and city of the fictional place, and the place is a variable which we will be sending at the runtime. And once again, I have to use this format instruction, which will come again from the partial variables. But this time, this parser is the object of pydantic output parser. And when we were using the JSON output parser, then this parser was the object of JSON output parser. So based upon this object, it will automatically understand, okay, which parser it is coming. Okay. That's it. And then we have this template ready. Again, we are going to call the chain. We have the template model and then parser. And we are invoking our chain, and we are passing place as Sri Lanka. So on this particular place, it is going to generate some kind of name, age, and city for us. Okay. With respect to this place. Let's try to run this. And there you go. It has generated a name, age, and city, which is related to Sri Lanka. All right. So this is how pydantic output parsers works. Any question, anybody in the output parser? String output parser, JSON output parser, or pydantic output parser? Are we clear with the concept? Okay. All right. So if you are clear, let's keep moving. Now let's go ahead and try to understand the chains. Now in LangChain ecosystem, we have 4 type of chains. Okay. One is simple chain, another is sequential chain, third is parallel chain, and then fourth one is conditional chain. So we need to see all of these chains. By the way, you have already seen the sequential chain, how it works. But let's discuss one by one all of this once again. So simple chain, which you have already seen, I'm taking one more example over here. I'm using this string output parser and I'm just creating a one prompt template that generate a 5 interesting fact about the topic. Topic will be coming from the when I'm gonna invoke the chain. So let's say topic is cricket, and this is my LLM setup. That's it. Now I'm gonna run this file, but at the last you see what I'm done. So I'm saying chain dot get graph dot print sky. So it's a function with the help of which we will be able to visualize our chain, how it looks like. So let's try to visualize this. When I'm gonna invoke this chain, how it will look like. Okay, so it has given the 5 interesting facts about the cricket, which is fine. But our interest is in this chain. So you see, this is how the chain looks like. So first of all, this is our prompt input, because when we are invoking this chain, we have to, of course, send the input to the prompt. So this cricket is our prompt input. It went into the prompt template. And then from prompt template, once our prompt is ready, we are sending that prompt to the chat OpenAI. In our case, you see, it's that's the class, and we are using the Grok LLM from the chat OpenAI. And then finally, you see, after the model, we are using the parser. So which parser we are using? String output parser. So it went to the string output parser. And then finally, the output of the string output parser is displayed. So output of the string output parser. So this is how this chain is visualized in these 5 steps. A simple chain. Same stories goes with this sequential chain. I'm not gonna run this, but you understood. Since it's a sequential chain, so it's gonna work on a simple chain only. Let's talk about the something called as parallel chain. Okay. Now from here, the things will get interesting. So let's see this. Now, here I'm just taking a simple use case. So I have this, text from on support vector machine. It's a algorithm available in the machine learning class. So just a bunch of text. Those who don't know about support vector machine, it's totally fine because we are not going to learn about this. So you can just consider it's a bunch of text on the SVM, support vector machine algorithm. And what I want to do is basically, first of all, I want to generate short and simple notes based upon this text. Okay, so LLM should go through this and it should generate a short and simple notes for me. Secondly, it should also generate a 5 short question answer from the same text. Okay, so 5 short question answer pair for me. And then finally, what I have to do, I have to combine both of them. Okay, I have to basically merge the notes, and this is like 5 question answer is going to be my quiz into a single document. Okay, so that's what I want to do. Now, if you pay attention closely, for the first task, if I want to generate a notes on this text, and also if I have to generate the question answer pair, 5 question answer pair or a quiz on the same text, these are two independent tasks, right? They are not dependent on each other, and hence it can be executed in a parallel fashion. So let's try to understand how, with the help of parallel chain, we will be basically able to do this. All right. Now, so what I'm doing over here, of course, I will need a string output parser, because here we don't require any kind of structured data kind of thing. LLM is by default gonna give me the output in a string. So let's go with the string output parser. Now I'm importing something new over here. I'm saying from LangChain core dot runables import runnable parallel. Now runnable parallel is a class with the help of which I will be able to build a parallel chain inside the LangChain ecosystem. That's why I need this particular class. All right. Now over here, you see, I'm going to use two models, not a single model. So this is my first model over here. Which LLM I'm using? GPT OSS 120 billion. And this is my another model, but this time you see my model is Llama 3.3 70 billion versatile model. So again, it is available on the same Grok engine. Let me show you. Let's go to the Grok. So you see from the playground, I'm using this Llama 3.3 70 billion versatile model. You can choose anyone, but I'm fine with this model. Okay. But the provider is same. It's a Grok provider only. So I have created the two instances of the model over here. It's a model 1, model 2. And this is my prompt template 1, where I'm giving this text as an input. And where is this text? This is my text on the support vector machine. It's some kind of topic on which I just want to generate a short note, as well as I want to generate 5 short question answer pair. All right. Awesome. Now, in the third prompt, I want to merge them. So that's why I'm saying merge the provided notes and quiz into a single document. And you see the input variables are nothing but notes and quiz. From where notes will come? From the first LLM call, notes will come. And from the second LLM call, quiz will come. And in this prompt 3, we are gonna just combine it. And here I'm defining the string output parser. Now let's try to draw the architecture diagram of how this will look like. So let's say here is our LLM number 1 and LLM number 2. So this text is always available for us. So let's say prompt template, prompt 1 and prompt 2. And we have the text available always this. Text means our topic, right? The SVM text which we have, the paragraph. Now the same text goes into this prompt, and the same text also goes into this another prompt template, right? When I say prompt, it's our prompt template. Okay. Now, what we are doing, so we need to from the first prompt, we need to send this to LLM so that we will be able to generate our notes. And from the second prompt, we should be able to generate the quiz. So you see, this two operation can be done in a parallel fashion. there is no sequential operation. Now, once we will get the output from the prompt, so of course we are using the string output parser over here. So let me just write parser. Okay. Over here also we have the parser. So this will be parsed and then this will also be parsed. And whatever result we are getting from both of these parsers, we need to basically combine them to another prompt template, right? So this is going to be our prompt template number 3. And again, we are going to call the LLM. And this time, maybe you can call LLM number 1, LLM number 2, because you have the result, right? We don't have to call 2 LLM. So it can be 1 or 2, anything. And then again, we are going to apply the parser in order to parse the result. And finally, we will get our output. So this is how this entire thing will look like. So at this stage here, what we have is a parallel chain, right? A parallel chain. And over here, we have a sequential chain. Correct? So it's a combination of parallel as well as sequential chain. So first of all, let's see how we are going to implement this parallel chain. And as I already told you, it's a runnable parallel. So with the help of runnable parallel, we are going to implement it. So you see what I'm doing, I'm writing a runnable parallel over here. And the way I'm writing a chain. So runnable parallel, it's going to be what? This chain and this chain, 2 chains, right? So you consider this big box as a runnable parallel. In this, you have this first chain and the second chain. So that's why you see what I'm writing. Prompt 1 goes to the model 1, goes to the parser. And the output is nothing but nodes. So from this, we are going to get the nodes. So this is our first chain, comma, this is our second chain, prompt 2, model 2, parser, right? And since we are using runnable parallel, LangChain is going to run both these chains parallelly, not on a single thread. Okay, it will create a 2 Python thread and it will run it parallelly because we are writing this both the chains inside the runnable parallel. So automatically 2 threads will be created and it will be run in a parallel. All right. And then finally, once we have the result of this notes and quiz, we are going to the prompt 3. So basically this part, prompt 3. And this, you see, I'm using model 1 because you can use any LLM, LLM 1, 2, doesn't matter. And then finally a parser. So this chain, right? And then finally, output of this chain, we are calling it as a merge chain. Merge chain meaning what? Output of this is basically going to have the quiz as well as the notes combined, right? Because you see over here, we have already combined it. And when you are going to hit this LLM, you will have the combined result of notes as well as the quiz. So that we are calling it as a merge chain. Now you see, after that, we are creating a final chain. So final chain is going to have what? It will going to have this parallel chain, this one. And then the output of this chain will go to which chain? Will go to this sequential chain. So that's why this merge chain, right? This chain. And that is going to be our final chain. And what we are going to do, we are just going to invoke this chain. That's it. So you see, we have this text, we have this chain, and we are invoking that chain with our text as the input. This is our text. And we are going to get the result. And we are also printing this get graph. Hope you guys are able to understand the entire flow of this parallel chain. And it's an interesting discussion over here. Now you imagine if you have any kind of parallel LLM calls, you can build this kind of parallel chains, combine it with a sequential chain, and you will be able to create any kind of sophisticated system with this kind of chains. Okay, so let's go and run this. Let's clear it and UV run parallel chain 3. And there you go. We got the output. You see, this is the quick notes and this is the short answer quiz. You see, question answer, right? And then this is how the, your architecture looks like, the flow. The same flow which I have explained to you. It has this parallel, this bigger box, and one branch is going this side, another branch is going this side. First prompt template, second prompt template, both are calling to the chat OpenAI model. Of course, models are different. Both are being passed by the string output parser. The results are combined over here. And then finally, the combined result is going to the third prompt template. Third prompt template is going to the, again, chat OpenAI. And again, it is passed by the string output parser. And then finally, the output of string output parser. Right? That's what we are doing it over here. Anybody have any question in order to understand this? It's a really strong concept because once you learn this, you will be able to create any kind of complicated GenAI systems with the help of basically chains.
Hey Sachin, hi, Vivek here. So Sachin, structure-wise, I am good. So there's only one question I have. I've been seeing that whenever you are running your output, right? Very first line it says cannot able to pass line number 4. I mean, what is that? I mean, I'm seeing.
It's just a python.env warning it is giving. Don't worry about this one. It is coming from this library, so don't worry about it.
Okay, then fine, all good.
Yeah, it's a warning. Don't worry about it.
Yeah.
Ideally, it should not come. Coming, it's fine, not an issue. Maybe they have updated their Python package. Maybe due to that, we are getting this warning.
Sachin, how do you define parser actually?
So parser is basically a kind of, you can say, object available in the LangChain, with the help of which we will be able to parse the output of the LLMs. Now, LLM can generate the outputs in the form of string. So in order to parse those, we use string output parser. If LLM is generating the JSON output, so in order to parse it, we have the JSON output parser, and we have the Pydantic also, which does the same thing. So that's a task of parsers. Hope you got the answer.
Yeah. Sachin, Gaurav here. So could you please go to that board that where you have explained the. Yeah. So for example, now you see like you have given prompt 1, prompt 2, right? So what can we interchange it? Like we are giving one whole prompt like a story and quiz in one go, and then ask from that to provide one for kind of short summary and second for kind of a quiz, and then give answer some different like response 1 and response 2, something like that.
See, so if you are taking that, like combining the quiz and short answer in a one go, so it will become a sequential chain. You don't require a parallel chain in that case. But just to explain the concept of parallel chain, I have taken the task, like from the same notes, I want to generate the quiz, and from the same text, I also want to generate the notes. So just in order to explain you, in real world, of course, you will not take this simple text and then you will do this parallel processing, right?
Correct.
In real world, you will have some real use case. Yeah, but in order to first understand, we will need some kind of simple use case so that we will be able to understand the entire concept of parallel chains, right?
Okay, I now understood what you said. Okay, yeah, thank you.
Yeah, no problem.
Sachin, still I couldn't understand the difference in parallel chain and runnable parallel chain.
Runnable parallel is a way with the help of which you build parallel chains. So there is no such class called as parallel chain in the LangChain. With the help of runnable parallel class, you see, we are using this runnable parallel and we are passing these two chains in this runnable parallel class so that these two chains will be run in a parallel sequence.
So you mean without runnable parallel, we cannot run these both chains together?
Yeah, exactly.
Okay, got it. Thank you.
No problem. Any more questions, anybody? All right. If no questions, then let's go to the next topic, which is our conditional chain. Okay, so as the name suggests, it's a conditional chain, meaning it will have some kind of condition, very similar to your if-else block. Maybe, it will run this chain or that chain, right? So it will come with the condition. So we'll take again a simple use case that which chain should run. So let's say the use case is this. What I have is I will have some kind of sentiment available to me, and I want to basically, classify that sentiment as a positive or a negative sentiment. Okay, based upon the feedback, basically. So this is the use case. Okay, a very simple use case. But sooner, I'm gonna convert this use case into a very useful use case. You will just try to correlate it. Okay, first let's go through this particular code, and then sooner you will see that how this use case will be very helpful in a real world scenario. So let's try to first understand this. Now, a new import I'm doing it over here is something called as runnable branch and runnable lambda. You see, I'm not using this runnable parallel, right? I'm using runnable branch and runnable lambda. Runnable parallel is faded out because it is not being used anywhere. Just I have imported it. But runnable branch and runnable lambda is required in order to build the conditional chains. Let's try to understand. So here is our LLM setup, which is fine. Here is my parser, string output parser. And again, what I'm doing it over here is I'm building a pydantic schema. You see, base model, and the schema name is feedback. It's going to be have only one particular key, which is going to be sentiment. And of course, it's going to have literally positive or a negative value, only these two values. And I'm also giving the description that give me the sentiment of the feedback. Fine. Now, I'm creating another parser over here, which is my second parser number 2. And this parser is coming from the pydantic output parser. And I'm sending this feedback schema to this pydantic output parser so that I will have the parser. All right. Now, you see what I'm doing? In the first prompt template, I'm saying that classify the sentiment of the following feedback text into positive or a negative, and we are passing the feedback, and then slash and format instruction also we need to pass. All right. And of course, feedback is our input, which we will be sending later. But in the partial variables, you see, I'm using the parser 2. Why parser 2? Because I need a structured output, and parser 2 is nothing but it's a pydantic output parser. And when we are going to use this get format instruction, so this will be passed as an input over here. So that's the first prompt I have defined it over here. Now here, first of all, I'm building my chain, the first chain. I'm calling it as a classifier chain. So I will have the prompt 1. The prompt will go to the model, and the output will be parsed by this parser number 2, and I will get my output. And this entire chain, I'm calling it as a classifier chain. So till here, it's a sequential chain, nothing more than that, right? It's a simple chain, basically. You have a prompt, model, and parser. It's even not a sequential chain, it's just a simple chain, right? Because when you say sequential chain, meaning you are combining more than 2 LLM calls. Here, it's just a simple LLM call. Now I'm giving the name as classifier chain. So this will basically able to give me the classify classification of my feedback, whether it's a positive feedback or a negative feedback. That's it. Then I have this prompt number 2. And over here, what I'm doing, I'm saying that write an appropriate response to this positive feedback. Now here, so let's say whatever the feedback I have, if it is a positive feedback, so you see, I'm saying write an appropriate response to this positive feedback. So meaning I'm already assuming that this feedback is going to be a positive feedback. And for the positive feedback, I'm writing this prompt so that my LLM will be able to write an appropriate response for that particular feedback. And this is my prompt 2. Then in the prompt 3, what I'm saying that you have to write a appropriate response for the negative feedback. So I'm assuming that this feedback is going to be a negative feedback. Okay. And this is my prompt 3. Now here comes the runnable branch. So now what we have to do, we have to create a change on a condition basis. So you see how I'm writing this. I'm using this runnable branch, and as the name suggests, branch meaning it will run on a branch basis. So either this branch or that branch, right? Now you just say what I'm doing. I'm writing a anonymous function over here, or lambda function, right? So I'm writing lambda x:x dot sentiment, meaning this function will take one argument, which is x, and I'm extracting the sentiment of it. So x is what? X is nothing but it's going to have this sentiment schema, sentiment key available to it. So I'm extracting that x dot sentiment. If it is a positive, I'm checking if it is equal to positive, I have to basically run this particular chain. And what this chain is, you see, we have the prompt number 2 going to the model, going to the parser. And by the way, this parser is a string output parser, not the pydantic output parser. You see, it's a string output parser. Then, and by the way, you see, this is entire thing is available in the form of tuple. Then after comma, I'm writing one more tuple. So again, I'm writing an anonymous function lambda x:x dot sentiment. So basically this function accept the argument x. I'm going to extract the sentiment from that argument, and I'm checking if it is a negative. In that case, I have to run this particular chain. So prompt 3 goes to the model, goes to the parser. Now, just focus a little bit over here. Prompt 2 is responsible for what? It is responsible for writing a positive feedback. I mean, writing a response for a positive feedback. And this one, prompt number 3, is responsible for what? It is responsible for writing an appropriate response for a negative feedback. Hence, you see, this is positive we are comparing, and here we are comparing negative. All right. Now, these two are good, but in Python, whenever we write if, elif, we have to also write else condition. However, even if you don't write else condition in Python, it works perfectly fine. But when it comes to runnable branch in the LangChain ecosystem, so this is nothing but it's a if else of LangChain universe, right? You have to write a third condition, which is else condition, right? Like if this chain won't run, then this chain will run. And let's say if both of them will also not run, then what will happen? So then this chain run, and this chain is simple. We are using something called as runnable lambda. So it's again a lambda function only. You see, in this runnable lambda, we are passing I'm writing an anonymous function lambda, which takes the input as x, and it just give you the output could not find the sentiment. That's it. So it literally give you the string output that could not find the sentiment. Okay. So that's the else condition of the chains. So either this chain will run or this chain will run. And if both chain will not run, then this chain will run. But trust me, if you have the feedback, either this chain will run or this chain will run. This chain will never be executed till the time you have the proper sentiment available in your feedback. Okay. That's it. So with the help of this runnable branch, we are able to create something called as branch chain. All right. So now it's simple. We have the classifier chain available over here. Now it's, let me just once again draw the diagram. You see, let's copy this same thing over here. So you will have the feedback, right? And then you have the prompt 1, prompt 2. Now, if the feedback is, first of all, you have to identify the feedback, right? Whether the feedback is positive or a negative one. So for that, what we are doing is, let me just close this. We are taking this feedback and sending it to the LLM. And you see, we are using this pydantic output parser so that, and this is the prompt number 1, where we are able to basically, with the help of this, we are able to classify whether our feedback is positive or negative. So this is the chain, classifier chain, right? We have this sequential, simple chain basically. LLM, and then finally from this LLM, of course, we are using the parser, but this parser is nothing but it's a pydantic parser. So I'm writing it in this way, pydantic parser. And this will give you the two things, either a negative or a positive response. So let's say if it is a negative, I mean your feedback is negative. So we are gonna take this route. If your feedback is positive, we are gonna take this another route, okay? And there is third route also. So in this third route, nothing will happen. It will just say not able to, what was that line? Let me go here. Could not find sentiment. And then it will just stop over here. Nothing will happen, right? This is the third route. So now let's say if it is a negative one, we are going to the prompt template number 2, not 1, because prompt template 2 is, of course, before LM. Over here you have the prompt as well. So here you have the prompt number 1. Okay. Prompt 2 to LLM, and then of course you have a string output parcel. So what it will does actually for the negative, it is gonna generate a negative response. Sorry, not a negative response, appropriate response for that negative feedback, right? And then finally, you see what we are doing, we are combining this classifier chain and branch chain. So basically, this chain and this chain is combined. This is not required. Let me remove this. And here you will not have two outputs. You can either have the output from this parser. So this is going to be your output. Or you can have the output from this parser. Okay, so it's a two distinguished output. We are not combining anything over here. So this is how this. First of all, you have this chain. Let me put this one over here. So this is your, which chain? Classifier chain, right? This chain. And then finally, we have this branch chain, which is this chain, right? This branch chain, right? So for negative, it will run this chain. For positive, it will run this chain. So it's a either or condition. And then finally, you see, we are invoking our main chain, which is the combination of classifier chain and branch chain. And we are just passing the, okay, feedback. Let's say this is the feedback. This is a beautiful phone. Now, by reading this sentence, what looks like? Looks like it's a positive feedback, right? And since it's a positive feedback, your first chain should be able to identify it's a positive feedback and it should take this route, and accordingly it should generate a appropriate response for the user. Now let's run this. Let's clear this and QB run conditional chains, and let's run this. And there you go. It has generated this response for me. Thank you so much for your kind words. We are thrilled to hear that you had a great experience, and we are truly appreciate. Blah blah blah. Okay. Now let's see the structure, and you will notice we have built a different diagram, but here we are getting a sequential chain kind of diagram. Now, if you have understood the chains, anybody want to answer why we are getting a sequential chain over here? I want to see your knowledge as well, what you have learned, guys. Anybody?
Because at a time only one node is running.
Correct, Gaurav. Yes, you're right. So you see what happened. This chain worked perfectly fine, but here we have taken the positive route, and hence only this particular branch got activated. And that's why it looks like a sequential chain, but it is not. So let's see what happened. You see, we have the prompt input. This one, prompt input, prompt number 1, the feedback. Then we have a prompt template. We are invoking our LLM, and you see pydantic output parser, this one, pydantic output parser. And then it goes to the branch. You see, then it goes to this branch chain, right? Branch chain. And from branch chain, we got the branch output. But here in the branch, only one path it can take, either this one or that one. All right. So this is how it is going. Now we are able to understand, okay, how it works. But let me now, try to connect this example with the real world example. So let's say you are, seller on Amazon or maybe Flipkart. And if you build this kind of system, and let's say, somebody, you are a seller, and let's say, you are very popular on maybe LinkedIn, on Amazon or maybe Flipkart, and a lot of people are buying your products. So what happened? A lot of people are, always types whenever they buy your product. Maybe a lot of people, 90 or 95% people write good about you, about your product, and 5% people also write some bad, because it might happen that something goes bad with your products. So you want this kind of system, a Gen AI system, where automatically whenever a feedback or a review will come to your account, a system should trigger and it should write a message according to the user sentiment. So if user has given a positive sentiment, a positive feedback, then this chain should activated, right? And this kind of response should come like this one. Thank you so much for your kind words, right? And it should happen automatically. Now imagine, let's say, user typed, and just after 30 seconds, he receive a notification, or she receive a notification that this message is there. Your customer will be happy, right? Because you are a seller and ultimately you want your customer to be happy. Now, but let's now talk about the second situation. So let's change this. Oh, I'm really frustrating with this product. Can I get my refund back? So let's say this is your response. Okay. Now your user has given this feedback, and you see, let's say if you are very popular, you won't be able to go and reply to each and every customer, right? You want some kind of this kind of system. So now let's say for this kind of system, your LLM, this system understood, okay, and it will be triggered automatically. And now it is gonna give some kind of reply, which is going to be appropriate for that user. So let's see what it will give. And you see it given this message. We need to change the prompt because it is giving in a, like email format. We don't need that, but that's fine. We can always change the prompt and it will work. But it is giving that, hi customer, thank you for taking the time to share your thoughts with us what went wrong. So basically, it's try to understand what is wrong with you. How can we, how you can reach us. So all of this information is given to that user. Now you think if something bad is also going on, your customer is able to, get this kind of information, and quickly they will be basically able to give some positive reviews for your product. So this is how this kind of system will be helpful in a real world scenario. All right. Hope you are able to understand why we have taken this example and where it can be helpful. Anybody have any question? Please go ahead.
Sachin, if we have, let's suppose in this condition, we have only one, I would say, condition that sentiment is positive or negative. If we have a multiple such parameter coming out from the classified chain, so we should be using the same lambda with multiple variables over there.
Yeah, you can keep appending the multiple chains in terms of like this tuples. As a tuple, you can keep adding it, and any one chain should be triggered. So you
No.
can.
So in tuple 48 line, you have one statement like one, I would say condition X is dot sentiment. Let's suppose I have another Y something or Z,
So you can take that. Yeah.
and we can put and like this.
Yes. Right. It's basically a lambda function syntax, right? All right, so I think we can stop over here. I hope you enjoyed the class. Today we have learned a lot of things. Let me just push this code.
Hi Sachin, Pratik here. I had one question.
Yeah, Pratik, please go ahead.
Yep. So what if the user has given a kind of contradictory statement as part of the feedback? So as at that time, LLM would decide on itself that it should go on a positive route or a negative route. Means
Give me that sentence. Let's test
uh,
LLM. Give me that sentence.
okay. I like the phone, but disliked uh, the the OS features of the phone or OS UI of the phone, something like that.
I like the phone, but I dislike the OS
Dislike
features.
the Oxygen OS of the phone, for instance.
Yeah, I'm just dictating, so give me time, okay?
Okay, sorry.
Yeah. I like the phone overall, but the OS is something can be, I mean, I don't like it and can be improved. Let's take this sentence. Okay.
Yep.
So LLM is a smart enough, right? It will be able to handle this. Thank you so much for taking to share your positive experience with us. We are thrilled to hear that. Your kind words are incredibly motivating and whatnot. If there anything else can we do, or if you have any suggestions on how we could make your next experience even better, please don't hesitate to let us know. So it is giving some this kind of information. Okay.
So it considered the
Yeah.
positive route and
Yeah.
gave us the output.
Yeah. If you want to have a like neutral also, so you can add that third chain also here. That based upon neutral feedback, the third the third chain will be involved basically.
Okay, got it. Thank you. And I had one more question regarding the runnable part, what we had ran during the Pereira run. So we had done two things. One was to have notes and one was to have queues. So and they both ran as part of different LLM inputs. So
Sorry, come again with your question.
yep. I had a question regarding Pereira chain, what we had ran. So at that time, we had ran two things in Pereira. One was for notes generation and one was for quiz generation. And
Correct.
both ran on different LLMs altogether.
Correct.
So there could be a possibility, means just a hypothetical question. There could be a possibility that if we have a large text, the notes which are getting generated and the quiz what is getting generated, they are, means there could be few questions which are not part of as part of the notes or something like that.
But
Because
you are generating this quiz and notes based upon your original text only.
correct.
So why like it will have the, I mean, quiz question will not match to the notes. It will basically, you are referring the same text, right? So it will have it.
We are the context is the same, but the LLM what we would be using was different, and
That's
notes
totally
in a
fine.
way.
That's totally fine, but we are giving the same context to both the LLMs, right?
Correct. That's true.
Yeah. But you are right. I mean, it might happen that, okay, in the notes and in the quiz, like in the quiz, you can have one question which is not available in the notes.
Yep.
That's totally fine.
Okay.
But that's not like idea over here that we want a very perfect system. Maybe you can change the prompt in that case, that your both the prompts will have the same notes, and you can always say that while generating the notes or quiz, you should always look for the original text, and like
Gotcha.
the notes and quiz should match. Or you can have the same LLM also. So right, same LLM you can call over here, so that you will be able to generate the similar kind of question. Like there is no going to be ambiguity on that.
Okay. Yep. I got the answer. Thank you very much.
No problem. Yeah. Okay, so I have pushed this code to okay, this one is still remaining. I just change it. No problem. Okay, so just check the code. It should be updated. Let me verify. Yes, indeed, it is available. All right, thank you everybody. Thank you for joining the class. We can stop over here.
Thank you.
Thanks everyone. Bye.
Yeah. Thanks, Sachin.
Thank you.
Yeah, good night.